Welcome to SV Union High School and Junior College. Let's discuss an important component in electronics, that is transistor. Let's see about the transistor. John Braden, Walter Braden and the William Shockley Braden are the three scientists who were the responsible for the invention of transistor. They invented transistor in 1947. Braden, with the PhD in mathematics and physics from the Princeton University, was a specialist in the electron conducting properties of semiconductors. Bratton, PhD, was an expert in the nature of atomic structure of solid at their surface level and solid state physics. Shockley, PhD, was the director of transistor research for Bell Labs. Their original parent name for the transistor was semiconductor amplifier. Three electrode circuit elements utilizing semiconductive materials. In 1956, the group was awarded the Nobel Prize in Physics for their invention of the transistor. In 1977, John Braden was awarded the Presidential Medal of Freedom. The three scientists who invented transistor. What is transistor? A transistor is a semiconductor device used to amplify and switch electronic signals and electrical power. It is composed of semiconductor material with at least three terminals for connection to an external circuit. A voltage or current applied to one pair of the transistor's terminal changes the current flowing through another pair of terminals. A transistor can amplify a signal found embedded in integrated circuits. Definition of transistor. Transistors are electrical devices which utilize a sandwich of p and n type of semiconductor materials. There are two types of transistors, NPN or PNP transistor. As the p-type material is sandwiched in between two n-type material, a NPN transistor is formed. Or if n-type material is sandwiched in between two p-type material, PNP transistor is formed. Terminals of transistor. Transistor having three terminals: emitter, base and collector. One of the n-type at the left is emitter, right is collector, and the central terminal p-type is the base. When contact is being made between materials in case of NPN transistor, potential difference develops at their junction and the emitter and collector being positive relative to the base. Let's see how the transistor connected. When the device is connected to a source of EMF with the emitter negative and the collector is positive, no current flows unless the EMF exceeds the critical value. As the electrons are unable to pass from the negative p type to the positive n type semiconductor, so cannot cross the base collector junction. The second source of EMF is connected to the base and the emitter, the base being positive relative to the emitter. The electron can pass from the negative N type to the positive P type. So the current flows across the base collector junction. In the circuit, there is a thick layer of N type semiconductor, a thin layer of P type semiconductor. So the current consists largely of the movement of electrons from the emitter pass into the base. The base has now an adequate supply of electrons, and as it is very thin, these come close to the base collector junction and are attracted into the collector to replace those that had migrated into the base. This reduces the barrier effect across the base collector junction and current flows across the transistor. Thus, a current fade into the base current causes greater variation of current flowing across the transistor. In this respect, the current fade into the base of the transistor has an effect comparable to that of a positive charge applied to the grid of triode valve. Uses of transistor. Transistors are used in preference to the valve in most modern equipment as they are durable, have a long life, consume less power, and need no heating device. As the power output is limited, they are suitable for use in the production of low frequency but fail to produce the high frequency current. The transistor is one of the most important components used in electronics. Even integrated circuits have many thousands of them within it. Many electronic products and their circuits rely on sensors in order to function. Most sensors provide only a small output current or voltage. It is necessary to amplify this current or voltage in order to drive an output device. A transistor is an semiconductor device which is a fundamental component in almost all electronic devices. Transistors are often said to be the most significant invention of 20th century. Transistors have many uses including switching, voltage or current regulation, and amplification, all of which are useful in renewable energy applications. Let's see the functions of transistors. Transistors amplify current. For example, they can be used to amplify the small output current from a logic chip so that it can operate a lamp, relay, or other high current device. In many circuits, a resistor is used to convert the changing current to a changing voltage. So, the transistor is being used to amplify voltage. A transistor may be used as a switch, either fully or with maximum current or fully off with no current. And as an amplifier, the amount of current amplification is called the current gain and the symbol is HFE. Let's see types of transistors. Types of transistors. Figure shows the circuit symbol of transistors. There are two types of transistors, NPN and PNP. With the different circuit symbol, the transistors can be used. The letters refer to the layers of the semiconductor material used to make the transistor. Most transistors used today are NPN because this is the easiest type to make from silicon. If you are new to electronics, it is best to start by learning how to use NPN transistor. The leads are labeled as base, collector and emitter. The base is denoted by B, collector is denoted by C and the emitter is denoted by E. Transistors are manufactured in different shapes but they have three leads. The base, which is the lead responsible for activating the transistor. Figure shows the construction and the symbol of transistor. There are two types of transistor, NPN and PNP. So this is all about transistors. Thank you. Thanks for watching.